All right, let's work through number 6, the investigative task on the 2024 AP Statistics exam, released FRQ. My kids told me they thought this was really easy for number 6, so let's see. We'll work it out, and then we'll see if I agree with them. Company sells a certain type of whistle. Price of the whistle varies from store to store. Julio, a statistician at the company, wants to estimate the mean price in dollars of this type of whistle at all stores to sell the whistle. Identify the appropriate inference procedure for Julio to use. Let's see if there's anything in here. It looks like we would use a one sample t-test for means. Wait a minute, wants to estimate the mean price. Estimate the mean price. Sorry, we're going to use a one sample t-interval. For the population mean. Estimate, not check against a claim. Describe the parameter for the inference procedure you identified in part A1. The parameter is the population mean of the price of whistles. All stores. Julio called the managers of 20 randomly selected stores that sell the whistle and record the price of the whistle at each store. Following is a dot plot of Julio's data. Summary statistics for Julio's data are shown in the following table. We have the mean, median, the range, okay? If you can't see that. Julio wants to examine some characteristics of the distribution of sample whistle prices. Describe the shape of the distribution of the sample whistle prices. Justify your response using appropriate values from the summary statistics table. Describe the shape. A custom BS. Center. Median price is $4.885 for the whistle. And unusual features, we will look in just a second to look at the unusual features. Let's do shape. Distance from Q1 to the minimum, from minimum to Q1 is 0.26. The distance from Q3 to the maximum is greater than 1. The distance from the median to the maximum is almost $2. Distance from the median, minimum to the median is only about 60 something cents. The median is pretty different from the mean, less than. So this tells me that I expect this to be a skewed right distribution, and the mean is greater than the median. Spread of the median price is given to us. We didn't have to justify that really. The spread, the IQR for whistle prices is 5.475 minus 4.51. Or $0.965. All right, unusual features. It looks like if we're going to have an outlier, it will be on the upper end. So let's check for outliers using the IQR method. So boundaries for outliers. Anything greater than, this is going to be Q3 plus 1.5 times IQR. And we already got the IQR here. So that's going to be, this equals 5.475 plus 1.5 times 0.965. That would be 6.92. Sure we did everything right. Yeah. So there are no outliers because the maximum. Okay, I'm describing. So I'm gonna say since the maximum is less than 6.9225, there are no outliers. On the upper end, let's go ahead and make the boundary here. Less than Q1, just to check, minus 1.5 times IQR. Oh, there it is on the next one. Yep, you're right. So we'll just go ahead and we'll put all that down here. We may as well do it now. This equals Q1 is 4.51 minus 1.5 times 0.965. That's 3.0625. And that means that the minimum is greater than that. Since the minimum of 4.25 is less than 3.0, greater than 3.0625, no outliers on the lower end. So from the summary statistics, we cannot tell any gaps or clusters. And then there are no outliers. Using the 1.5 times IQR rule. Let's proceed. It can often be difficult to determine whether the distribution of sample data is skewed by looking at a graph of the data and the summary statistics, particularly when the sample size is small. Oops. Thus, statisticians sometimes measure how skewed a data set is. One such measure is Pearson's coefficient of skewness, which is calculated using the following formula. Right here, 3 times the sample mean minus M over S, where M is the sample median and S is the sample standard deviation. Calculate Pearson's coefficient of skewness for Julio's sample of 20 whistle prices. Show your work. So we'll get our table of data back here. So Pearson's coefficient of skewness is going to be equal to 3 times the sample mean was 5.12 minus the sample median was 4.885 divided by the sample standard deviation was 0.743. So let's do 3 times 0.12 minus 4.885 divided by 0.743, and we get 0.94885. Following graph shows conclusions that can be made about the shape of the distribution of sample data based on Pearson's coefficient of skewness and sample size. So sample size, ours was 20. Indicate the value of the Pearson's coefficient of skewness you calculated in part C1 for the appropriate sample size by marking an X on the preceding graph. So we got 0.94885. 0.94885, this would be about 0.94885 would be about right here. There would be our X. And consider your work in part C. Let's see if I can get it all in there. What should you conclude about the shape of the distribution of sample whistle prices? Okay, so that tells us that the X is in this white region here, so the distribution of sample data is considered strongly skewed. Julio's inference procedure in part A1 needs one of the following requirements to be satisfied to verify the normality condition. Sample size is greater than or equal to 30. If the sample size is less than 30, the distribution of sample data is not strongly skewed and does not have outliers. Using your response to D1 and the preceding requirements, is the normality condition satisfied for Julio's data? Explain your response. No, the normality condition is not satisfied. Even though there are no outliers. According to Pearson's, what do we call that? Coefficient of skewness. The distribution is strongly skewed. So the normality condition is not satisfied. And I would have to agree with my students that that was a pretty easy question 6. So hopefully everybody did well on it.